Okay, so note 7.4, we're looking at we're finding the function from the given information. So it's kind of the opposite of what we've been doing. So on your function, you're going to have a, which is the coefficient, and then x minus your x-intercept, because normally we would find your x-intercept by setting your numerator equal to 0 and solving for x. And then x minus your whole on top and on bottom, because your whole, remember, is what cancels out, the factor that cancels out. And then x minus your vertical asymptote on the bottom, because we're setting our vertical asymptote is what causes our denominator to be 0. Alright, so a is your coefficient. It says to find a, because you're not going to know a, you're going to be setting your equation equal to your y-intercept, which means your x will be 0, and then you'll be solving for a. If you do not have a y-intercept, then you are using your horizontal asymptote. Okay, so the first example, we're going to be given this information, and then we're going to write the appropriate function. So we're given the x-intercept, y-intercept, vertical and horizontal asymptotes, and then whole. Your preliminary equation is going to be everything that you plug in, and then we'll have to find a. Okay, so we're going to write the preliminary equation. We have f of x equals a, and then if you look back up at the top, you're doing x minus your x-intercept. X-intercept is 3, so x minus 3. And then x minus your whole, but notice we do not have a whole, so we don't have another factor on top. Denominator is x minus your vertical asymptote, which is -4, so that would make it x plus 4. And then again, we don't have a whole, so we won't have that x minus whole. Alright, so once we found that, we are finding a by using our y-intercept. That helps us with finding a. We're plugging in a 0 for x and a -3/4 for y. F of x is the same thing as y, so we're replacing that, and then we're replacing x with 0. So you're going to have a -3/4. On top, you're going to have -3 times a, so that's -3a, and then on bottom you'll have a 4. So notice -3/4 equals a -3/4 a. A would have to be a positive 1. So when we're writing our final equation, we have f of x equals, we're replacing a with whatever we found it to equal, which is 1. You don't have to write that 1 since that's the coefficient in front, but you can. And there's your function. You can check your answer by just plugging in. We know how to find the vertical asymptotes, we know how to find the horizontal, and then we also know how to find the x-intercept, so you can check it by doing what we were doing last week. Alright, example 2. We're given information, and then we're coming up with our function. So same thing as number 1. So our preliminary, we're not going to know a. You're going to have x minus the x-intercept. We don't have an x-intercept, so then you're doing x minus your whole. Okay, on your whole, remember when we were finding wholes, that is what your factor that cancels out. To find the x value of your whole, remember you were always setting your factor that canceled equal to 0 and solving for x. So whenever you're plugging it into your function, it should be x minus your x value of your whole, which would be x plus 2. You'll also have that on bottom because that's what cancels. And then also you have your x minus your vertical asymptote on the bottom, which is 2, so that would be x minus 2. Alright, so we are finding our a by using our y-intercept. So x is 0, y is a half. So on top you're going to end up with a 2a, and then on bottom you're going to have to multiply -2 times 2 to get -4. So that reduces to a -1/2 on the right side. So a would have to equal -1/2 1, because a negative 1/2 times a negative 1 would give you that positive 1/2. So plugging into your function, we're going to have negative 1 as our coefficient, so you can just write negative, and then x plus 2 over x minus 2 and x plus 2. Alright, if you want, once you get to this point, you can go another step and write your reduced form after you cancel your common factors out. So if you canceled out those, you're going to have a negative 1 on top over x minus 2. So I'll accept either answer, your final equation or your reduced equation. Alright, so now we're going to do we're going to actually be looking at the graph and determining our x and y-intercept, vertical and horizontal asymptotes, and then your whole. So then we can find our function. So the x-intercept, where it crosses the x, would be negative 2, 0. Make sure you write that as an ordered pair. Your y-intercept would be 0, 2. Your vertical asymptote is where they're both approaching, but never ever reaching. So notice we have two parts, which means we'll have one vertical asymptote. So look in the middle of those two. Vertical line crosses through the x-axis, so that would be x equals, and notice it crosses at negative 1. So there's our vertical. Now you're looking at a horizontal asymptote, so in between those two, notice it's approaching this horizontal line. It crosses the y-axis at positive 1. Your holes, if you look at your graph, there's not any open points, so we do not have a hole, so you can just write none. And so now we're going to use our function from the front to plug in and find our new function. Alright, so we have f of x equals a. X minus our x-intercept, which is a negative 2, so that would end up being x plus 2. And then x minus your whole. We don't have a whole, so we shouldn't have another factor on top with that x-intercept. On bottom, we have x minus your vertical asymptote, which is negative 1, so that would make it plus 1. And then again, we don't have a whole. Alright, so now we're finding our a by using our y-intercept. So that's 2 equals a times 0 plus 2 over 0 plus 1. So we're going to have 2 equals. On top, we're going to have 2a over 1. So a would equal 1. So function would be 1 is your coefficient, so x plus 2. You don't have to write that 1 in front. And then x plus 1 in the denominator. Alright, so let's look at 4. Still doing the same thing. So x-intercept, notice there's 2 of them. There's one at negative 3. And then there's one at positive 2. Anytime you have 3 parts to your graph, you're going to have 2 vertical asymptotes. So notice the previous example, we only had 2 parts and we only had 1 vertical asymptote. So we should have 2 vertical asymptotes. Notice there's not a y-intercept. It doesn't cross the y-axis. Looking at our vertical, we're going to look at the far left piece and then the middle piece. Notice those two are approaching x equals 0. And then look at the middle piece and that right side piece. It's approaching x equals 5. Horizontal. On horizontal, remember you're only looking at the outside pieces at where they're both approaching. You're always reading your graph from left to right. So notice this line is getting closer to y equals negative 1. We're not able to see all of that graph, so it will be getting closer to that y equals negative 1. Alright, we have a hole in our graph. Remember, a hole in the graph is an actual order pair, so that's 3, 1. And then we're going to have to come up with our function. So f of x equals a. Notice we have two x-intercepts. We're going to have to write two different factors for that. So that's going to be x plus 3, and then the other one will be x minus 2. So you have two different ones because you have two different x-intercepts. The whole, remember we're only using the x value because that's what we do whenever we find the whole, is set the factor that canceled equal to 0 and solve for x. So that would be x minus 3. That will also be on the bottom because that cancels. All right, we also have x minus the vertical asymptote on the bottom. Notice we have two vertical asymptotes. If we do x minus 0, we get x. So don't write x minus 0. Just put x, and then the other one will be x minus 5. All right, so now remember we use the y-intercept to find your a, which is the coefficient. Notice there's not a y-intercept. So look at your horizontal asymptote. It's y equals a -1. So remember, check your degrees. If it's less than, it's y equals 0. If it's greater, it's none. Notice it's neither of those two, so which means it has to be y equals a over b, which is the ratio of your leading coefficients. If we know that number is the ratio of our leading coefficients, we know a has to equal -1 in order for that to match our horizontal asymptote there. So put a negative in front, or -1. Okay, or you can write your reduced form. Those would cancel. You would have negative x plus 3, x minus 3, over x and x minus 5. Alright, now let's take a look at the back. So the back, we're doing some transformations. So we are going to use the graph to sketch the following functions. So we're starting with f of x on the original. The vertical asymptote, it's crossing the x at 2. The horizontal is crossing at y equals 2. And then your x-intercept is 0, 0. And that's also your y-intercept. Okay, so that we're starting with that. Then we're translating it. So if you look at number 5, notice it says f and then x minus 2 in parentheses. That inside parentheses is a horizontal shift. So if it says x minus 2, you're going to be shifting to the right 2. And this is a vertical shift. And you'll be going up 3. Now, the easiest way to do this is to shift your intersection of your asymptotes. So notice here, the intersection of those two would be 2, 2. So I want you to find that 2, 2. And I want you to shift that point, right 2, up 3. So there's our new intersection of our asymptotes. Alright, so then we're going to plot some points on both sides. If you look at this intersection point up at the top, we're going to find a point that's on our line. So notice we went left 2, down 2 to get that 0, 0 point. So let's do that on our new intersection point. Left 2, down 2. And so that would be that left side of our vertical asymptote. Same thing to the top one. Find a point. We can go right 2, up 2 from that intersection point, and that would be a point on our right side line. So same thing, right 2, up 2 from that intersection point, and then you have that right side graph. So translate your vertical and horizontal asymptote, the intersection point, and that makes it easier. Okay, so the last one we have f of x, which is our original. We're subtracting 3, which means it's only going to be going down 3. So the intersection point is usually at 2, 2. We're going to go down 3. So there's our new intersection of our vertical and horizontal asymptotes. We're plotting those same points from the original, so left 2, down 2, and then right 2, up 2 will be your other. Okay, there's other ways of doing it, but this is just one way. You could also just shift each point down 3, and it should give you the same graph.